Programs are collections of definitions. We've now learned a lot of different ways to define things, so we're going to review them right here. First, we had constant definitions. These came in the form of saying things like define pi as being 3.1415, or define my name as being Dr. Bart. We've defined this name to be the same as this value, and once we've done so, it can't change. We've also learned how to define functions, function definitions. Here we use the define keyword again, and we take the name of a function, like say a simple one such as add, and then we can give it some parameters, and we can create a body for this function, such as this very simple addition function. So this is just wrapping the regular addition function, giving it a different name, saying, hey, when we take these two parameters, we'll add them together and return the sum. So that's using the define keyword. Normally you'd also give a signature, purpose, unit tests, the whole shebang. Now, those were the two using the define keyword. We also learned about a third keyword to make structure definitions. So there we say define struct for a dog, for example, has a name, a breed, and an age. Or maybe a cat could have a name and whether or not it's fluffy. So now we have two different structs. When you create a struct, it also automatically creates a bunch of functions, 2 plus n, one constructor, one type predicate, and then one selector for each of the different fields. Dogs have 3 fields, so they get 3 selectors, dog name, dog breed, and dog age. And cats have 2 fields, so they get 2 selectors, cat name and cat fluffy, huh? So, structure definitions, we're using the define struct, not define. We have a few other types. We have enumeration definitions. So these are not defined using the keyword define or the keyword define struct. In fact, they're only defined using comments. We say something like, a fruit is a string, but it's only either a banana or an apple. We could also add some more, but the idea is that for an enumeration definition, it can only be one of several finite things. But it also has a simple base type. A fruit is always a string no matter what, but it has to be one of these more specific strings in particular. Kind of similar to this is the interval definition. This is a type that is a number in a finite range. So an age is a number, for example, between 0 and 100. We also saw this in the case of things like BMI. You know, BMI value is a number either between, say, 0 and 20, and 21 to 40, and 41 to 60. So it could be a set of ranges, could even just be a single range, but the idea is it's a number in some set of ranges. And that's an interval definition. Then we have itemization definitions. Itemizations are very similar to enumerations, but they don't require them to all be the same type, so they're more complex. An example here would be an animal is either a dog or a cat. Dogs and cats were defined up here. You know, a dog is a type of struct and a cat is a type of struct. They're different types of things. It's either a dog or a cat. And an animal itemizes them. It says it's either this or that. As opposed to an enumeration where, you know, it's a simple type. It's just a string, or just a number, or just a Boolean. We have now learned one last kind definition. That's the list definition, and this is when we have self-referential data. An example of such a thing is a list of numbers. Is either empty or a cons pair, where we say a list of numbers is cons number list of numbers. And this recursive definition involves itself. So this is technically an itemization, but we treat it a bit differently because it gets its own template and has lots of really cool features that are going to take us through the next phase of the course. There's a handout online with more review of all these different types of definitions, but from here on out, you better start getting comfortable with all these different types of data.